we're going to be learning about the volume of revolution, and we're going to do that by answering this question. It says, determine the volume of the solid generated by rotating the function about the x-axis between 0 and 3, and y equals the square root of 9 minus x squared. We have to focus on 3 aspects of this question, which tells us that the rotating function is going to be about the x-axis and is between 0 and 3, and y is the square root of 9 minus x squared. Y is also a radius. The formula we're going to be using is this one that says pi is times the definite integral between 0 and 3, or a to b, and in our function here, our a to b is 0 to 3, times our x squared times d of x. Now if we look at this graphically and we insert a rectangle here, the length is going to be the y, which is given to us as the square root and the width, delta x, is going to be our dx. Now this radius here can be plugged, this function here can be plugged in as our radius here. And don't forget that all is squared, d of x. And when you square a square root, you get the same value under the square root. Our next step is to to do the antidifferentiation of this equation right here. And the antidifferentiation of 9 is 9x. And antidifferentiation of x squared is x cubed divided by 3. Okay? The next step is to plug in R3 and R0. So it is going to be 9 times 3 minus x cubed minus 3, all minus, well, you know what would happen when you plug in 0, you'll get 0 out. So when you plug it all in, this should be 3 right here. When you plug it all in, you get 27 minus x, 3 cubed over 3 will give you 9, and 27 minus 9 is 18. And don't forget this pi here, so it'll be 18 pi. And that'll be the volume as a solid, that'll be the volume generated by the rotating function 9 minus x cubed, square rooted. And that'll be all. Thank you.